Hey Vox, what's up? How are you doing? Just got a haircut and a beard cut and a facial, and the dumb guy didn't bother to remove all the blackheads. There are a few still remaining on my nose. So there's that. This is how my day is going. I may have to go back tomorrow or day after to get it all sorted out again. Uh, in the meantime, uh, let's get to some of my emails. This is with respect to the SM120 RTX 6000 5000 Blackwell support for native NVFP4 MOE kernels. Add step 3.7 flash. Add QDSL GIT warmup cache init. Use list accumulation. Add Lava 1 Vision 2. Returns an empty assistant mask for VLM processor. O1 memory mode for episode aware sampler. Fix FP4 arch. Yeah, and there was this I am Lucknow event with respect to startups that I had to attend tomorrow. Uh, let's search for the email. I don't know how it was removed from the tasks. Yeah, this was the email. I put it in the task. I didn't find it. I was unable to find this. I'm putting it again. Let's hope it stays here this time. It's the AI Day for Startups India, which is happening from 9 a.m. to 5 p.m. tomorrow. So this will be a fun event. Since I am a part of community, so I kind of got easy access to it. Lucknow's ecosystem AI. The next email is with respect to add RVV path for W4A8 int 4 games. HF exporters. VLLM. Return logics for semantic segmentation. Better processing tests. Remove unnecessary loaded weights method. D-type. Silently node on node of concrete D-type node mode. Curocont. Add diffusion gamma support. And no output path for custom backends. PS. AMO file. Add parakeet RNT. Enable NIXL EPLP communicator. MOE SM120 RTX Pro 6000. Intel for MXFP4 W4A16. Tom's hardware. Vision rope refactor. CUMCPY batch, I think. Tensor descriptor TD adoption strategy for VLLM Triton kernels. Yeah, this is the unisex saloon I was talking about. The services last time was good, but this time, yeah, they blundered. Vision group, layer module, then the final position embeddings, Fusesoft Max encrypt top-K CUDA kernels, enable SC cache for Rust build under CUDA Rockum, update PRCI security gate, parallel agnostic FS tier, cache for single full attention group. This is the controller that I have. Got to give it some love there. 8-bit 2 ultimate 2 wireless DCP support for hybrid attention, VRAM semaphores, infra, KV offloading, reset cache. This is Hugging Face speech to speech, tool only codecs, enable Chameleonia, quadricoder, 3 MT for auto approver, export VLLM, demo, chatbot. This is Voxtrel real time, boot OOMs, fixing, and other things. Look, my blueprint, Autoware Foundation, Slam to Lanelet to. Migrate Marlin kernels, enable MX FP4 LoRa test, okay. Says by NVIDIA, Agentic AI, Open Hackathon. A tiny auto scientist, this is up to 10 billion parameter models, ranging from zero point 0.8 billion to 8 billion range. So that's what has been released, and I've been trying on auto scientists, and I will let you guys know the results soon. This is code Vipassana. We jokingly call it the Vasana. Vasana season 15. Lust, for those of you who are listening, who are not from a Hindi background. I do not understand Hindi. And I will give these jobs a try. Let's see if I'm able to crack these interviews. And if I get one, I will be streaming everything live. Open mode with model labs versus agent labs and what untrainables are a go. So this is silent degradation of AI R&D help dominated discourse. Representative representative critiques came from Nigel Lambert, Martin Casado, Dr. Fefe, Antiras, Clement D. Langio, Dean W. Ball. This is the system story landed immediately. Diffusion VLLM units of diffusion comma is the first diffusion LLM natively supported in VLLM, citing 1200 plus output tokens per second at batch size 1 on single H200 at FP8. Agent tooling infra and benchmarks around uh, the benchmarks are shifting from preference to trace based agent metrics. So long horizon uh, and 30-minute traces which span dozen tool calls. Hmm, that's kind of cool. Memory orchestration environment control keeps maturing. Hermes agent profiles Write gate approval controls from memories and skills updates. Yeah, this is Cohere's North Mini code. Some of the metrics they appeared bad and some good. The weights are on Hugging Face. This is this Hugging Face announcement blog. So the parameters for this model is 30 billion, and this is the Cohere Code Agents team. These are the benchmarks that you can see here. 36, and it's comparing against 23.6. So uh, it's not as good as it should be if you compare it directly with Gwen. So these are the post-trading strategies that they worked on. The phase one and the phase two, the supervised phase training and the post-training phases. This is the agentic reinforcement learning with verifiable rewards, asynchronous reinforcement learning loop. This is the SWE bench verified. This is the terminal bench P2. Internal human evaluation benchmark. Code explanation, editing, data visualization, implementation from scratch. I don't know what the strategy was for releasing it because they aren't state of the art right now and they could have performed an additional steps to make the model good on different tasks. Because as things stands, I won't recommend anyone to use this. DeepMind route diffusion. Gamma, this is a good model. So I'd gone through this in great detail, specifically the post that I shared on X and LinkedIn. In my profile, you will find it. This is a very good article by Martin, I think. He is in Google right now. Yeah. Martin, if you go to his profile, he is in Google DeepMind right now, and he wrote a great article explaining the basics of LLM using diffusion. You can see the denoiser here, the encoder, the LM head, and words, and a token embedding layers, and the denoiser, which kind of feeds into the LM head and the canvas, which is updated at the end. All the updates at once, which comes out. So you guys all already know about autoregressive models, because generating a single token for single user is surprisingly cheap in terms of computation. It at each step, a significant portion of the time to generate a token is spent loading the weights from memory and not the actual computing. During decoding, these regular transform models are memory bound rather than compute bound. This means that, for instance, the time it takes to generate one token is the same for one user as it is for 256 users. The reason for this is that the weight only needs to be loaded from memory once per step, regardless of how many users are being served. This means that whether we multiply those weights against one user's vector or those 256 users, the cost of moving the weights into memory stays the same. And so they batch it all together and you get the same amount of work for nearly the same cost. Uh, of course, this is not all free. This depends upon the chip itself. And if you are serving it the LLM might be serving too many users and lacks the compute instead. So this is a kind of a roofline plot that you can visualize it as. It shows the impact of increasing the chip's performance, how long it needs to spend to generate a token versus the chip's memory, how fast it can load from the memory. So there's that. While one only serves user batching, the LLM memory bound and loads a large number of bits without actually doing much computation. The more we increase the batch size, you approach a right point where the hardware is properly utilized. Thus, while batching is great for serving many users at once, there's nothing to be gained for the individual users. And diffusion gamma kind of flips the script. Instead of generating one token each for 256 users, what if they generated 256 tokens at once for one user? So this is the idea behind diffusion gamma. Uh, the model starts with a sequence of 256 randomly initiated tokens called canvas. It tries to choose better tokens for the entire canvas all at the same time. By predicting 256 tokens at the same time, the compute budget of 256 tokens is now focused on single user instead of spreading it across many users. Of course, predicting so many tokens at once is very difficult, and model will have a hard time predicting tokens to 254 without knowing which tokens came before it. How the first two tokens are great, but it slowly starts outputting nonsense. The first pass of diffusion gamma on this canvas tends to produce reasonably accurate tokens at the start of the canvas, but the poor ones towards the end they tend to diverge. Distributed in inference. Let's watch this first.
Open Nebula. So
hello everyone, and welcome to NVIDIA series of conversations on AI inference. This time, this is AI inference at scale with NVIDIA Dynamo with G
zones with the single nodes anywhere, which will be interconnected through the public network with your control plane.
Are approaching these problems and how actually NVIDIA Dynamo fits into the picture. Few words on NVIDIA Dynamo. You will hear more from Seb on this, but in general, NVIDIA Dynamo is a framework, higher level framework, which abstracts away some of the.
We know that. So what?
If we will be having too many of them, so please use this chat as interactively as possible. Today, we will discuss inference because over the last year, it became obvious to everyone basically that now it's not just the engineering problem of placing the things somewhere so that they run, but it's the real AI infrastructure challenge, the one which is moving the infrastructure decisions, the one which is deriving the state-of-the-art solutions. And challenges are plenty in this domain: performance, cost, sovereignty. We will try to touch every of those from both perspectives today, all from technical perspective. How can they be solved, like using the development tools, and also from business perspective, what are actually the challenges from the business side? How do they meet together, and how do they combine in one platform? We'll look at how Gcore and Orange are approaching these problems and how actually NVIDIA Dynamo fits into the picture. Few words on NVIDIA Dynamo. You will hear more from Seb on this, but in general, NVIDIA Dynamo is a framework, higher level framework, which abstracts away some of the peculiarities of the VLLM, SGLang, and TRT-LLM engines and adds the cluster level performance. Because usually one engine can host one model on probably multiple GPUs. When you start thinking cluster level, you will need some optimizations like KV cache aware routing that we'll cover later on the cluster level. And today, actually, the challenge is one layer up. We'll cover that as well on the routing between the clusters. For the agenda, we will first have about 20 minutes spent into some slides that we have prepared to actually gather your questions so that you can base them on what the companies are actually sharing today. So we will have first Seva present more technical description of the platform, and then Nicola present some more of the business outlook on how that works. And finally, and I guess it's important for developers, you will see demos. 2 demos of different levels of the same platform to understand how does that actually feel for your probably agentic development, your own coding, and you will be able to figure out that for yourself. I think I've covered all the topics I wanted to. It was quick. So Seva, could you please introduce yourselves and explain about the G-Core platform and how Dynamo is integrated there?
Sure. Thank you, Dmitry. Hello, everyone. My name is Seva Weiner. I'm Product Director for Cloud and AI at G-Core. And let me share the slides. Yeah, I think that, so first of all, let me clarify about the G-Core. I think that so maybe audience maybe hear about us, maybe not. So we are a global infrastructure provider, more than 12 years in the market, and providing the networking, security, and the compute and AI services to our customers in a global scale. So we manage more than 210 points of presence around the globe, and very close working with NVIDIA team on the AI direction, especially on the inferencing and integration of the NVIDIA Dynamo in a global scale. So to have overall understanding, so we manage a lot of point of presence. We have a very big network backbone, more than 230 per second network capacity, and also we manage big GPU fleets around the globe. And from the nature of our business, when we started to shifting into the inferencing part, we are already thinking that so distributed inference, it will be one of the crucial part for the overall workloads and the real-time interaction with the models. It will be one of the big challenges, and also to cover the data privacy, but also the real-time interaction with the models. And we already see that too. A lot of things happening right now in the market related to the image generation, video generation, and it's naturally should be distributed around the globe. And again, not waiting when any kind of the images or videos or potentially robotics parts will be very sensitive on the latency perspective. And also very important related to the data privacy to have, again, the all necessary certificates to be GDPR compliant, especially in the Europe side. So as we base our headquarters based in Europe, in Luxembourg, so it's very important to have all regulated stuff. And Europe, it's very, very hardly controlled around how the data processing and also the everything related to SOC 2, PCI DSS, financial part, and ISO. So it's very, very important for all customers. And on the distributed inference itself, so I mentioned that, so latency, how you can distribute your load, it's very, very important. And when we saw the huge boom of the AI, so we see that's a lot of infrastructure allocated to the training, but we see the more practical usage at this moment, and all workloads shifting from the training to the inference. So the real practical usage to integrate to the business application and different verticals. And for sure that, so the overall market size to 2030 will be $70 billion. And for sure that, so one of the major part is the latency and how to distribute that, where we believe that, so the telco will be one of the crucial players on this market. That's how they build their network backbones, how they can interconnect their GPUs with their network is one of the crucial USPs which they can offer for their enterprise customers. And we started, and I mentioned a lot about the public service provider. So we started also our distributed inference as the public service offering. And for us, it's very crucial to providing the very smooth way how the end customers, how the end enterprises can run their inference workloads, models, or AI applications in 3 clicks. And you don't need to have a deep knowledge. So how to build the Kubernetes clusters, how to run the additional tools, how to optimize and running the NVIDIA Dynamo, optimize the models, how to build the global KV cache. So all of those work we done on ourselves, plus the additional things to also interconnect all our point of presence to optimize the networking, the caching, and everything, and providing the one-click button where you can decide the model, you can decide the regions, you can decide the scale, and click to deploy all of those models. And we can route the request on the proper manner to have the best latency, to finding the cache, defining the way where the model up and running in a proper way. And for sure, that's for security reasons. So how it will be routed from the Europe to Europe, in the US to the US customers. So it's very, very crucial part. And also a lot of things around the infrastructure optimization and also the model optimization. It's one of the crucial part. But this is a public service. Telecoms and everybody would like to have the product which they can build and manage in their infrastructure. And that's why we also, like NCP provider, shifting to the ISV part. And we decide that so what we will build for our clouds, we can build as the software stack, which fully independent from the G-Core infrastructure and deliver to our customers. But before, I would like to cover our part, so how the NVIDIA Dynamo fully integrated to our product and services and how it works in under the hood. So the end customers can have the option where they can run the dedicated endpoint, where the full GPU allocated for their dedicated model, and they can utilize that super easy. But also, so the token factory itself also should work as the single endpoint, which customer can use any kind of models which are available from this single endpoint. On the NVIDIA Dynamo, so it helped us to providing the different options and also the large language models based on the different architecture, including the aggregated topology, also disaggregated prefilling and decode, and also we can have the encode as the separate workers, prefill and decode, which will go through the router and also modify depends on the model type. So we can define strategies, so how it will be provisioned for the end customer to provide the global KV cache and also to have a maximum performance plus optimized type of GPUs which will be serving specific service. Everything goes through the NVIDIA gateway where the customer can utilize per token based and use super on easy way their models and services through our platform. One of the most important parts, which Dmitry mentioned that, so everything related to global KV cache can be running in the single region, in the single cluster with your deployment. But when you have not only one data center, but you have multiple sites, like one data center or multiple data centers, but with the separate clusters, so you would like to provide your customers the best latency, the best response, the best time to first token, and everything which related to the also optimization to your numbers of users which consume your models, and also to optimize the latency and the routing to the specific model. In this way, we are very close working with NVIDIA to providing the new solution based on the AI grid, where we can combine the policies based on how you would like to aggregate your different data centers into the single endpoint, any custom point, and applying the smart routing based on the latency. So it's defining that, so the internal endpoints and the latency, which will be also related how to route to the specific model. It's also related to the cache awareness, so to not processing every request to the specific model. So we know that, so where the cache is located and what the best way to go into the specific cache environment on the region to not process every request from the end customer. Also, it's related to the economics, related to the overall price in the region, about the health, that so the model is up and running, your environment also healthy, so we can route this request to the specific endpoint based on the readiness probe and leanness probes, and also overall utilization of your GPU clusters, which can also process the end customer requests to not have in the queue when the end user will wait for the processing their prompts. Based on that, so we build our solution, which we call Everywhere AI, which contain control plane, data plane, which support the air-gapped environments and deliver that to the end customer. We offering the option where we can have the AI applications, which we built on our site, optimized for open source models, for specific GPU models, also optimized and putting the NVIDIA Dynamo on that, and also to have an option to click one button, set the region in your environment, in your GPU data centers and regions, and run those models. Also, it's capable to provide dedicated endpoints. It's also contain the training tools like Manage Learn, Manage Jupyter. It's also can run the vector database for embedded models. But our ultimate goal to have a single door for the end customers to aggregate their all GPU data centers, to utilize their network backbone, to also be efficient to providing all those policies which we built and distribution which we granular providing to the end customers, so how they would like to route their request, and also all benefits from the telco providers with their smart routing, with their optimization network to have the best latency from the end customers, and also to providing the fully sovereign solution which fully controlled by the end customer on enterprise or by the telco to be sure that so the all data stayed on the customer side. So on the control plane side and data plane side, our Everywhere AI solution and platform fully Kubernetes native. So it's basically contained the open source technology, also including the NVIDIA Dynamo, and we're providing the very easy tool to have the self-service portal, API, SDKs, and Terraform to manage your environment through the single door. And also, so we have one site control plane, but also it can be multi-site control planes which synchronize with each other. And it's also related to the data plane. So when customer will decide that, so I would like to deploy Kimi model in a region in Europe, for example, in Paris and US. So potentially it's two separate Kubernetes clusters with the workers, which will be synchronized the states when they deploy the model. So they synchronize the states. And all those two deployments will have the internal endpoints, which is connected to the single any custom point. And the smart routing, which you described with the policies, will decide that, so how the route the request from the end user by specific rules, by the latency, by the cache, and also to understand that, so the end endpoint also available and healthy, or we need to route to the another one. That means that, so it's very flexible to aggregate your different applications, different GPU models, and have a very distributed way how you can provide the single endpoint to your business application. And also all of those logic and optimization go through the platform by default.
Seva, let's stay for a second on this slide because I think we have a relevant question from YouTube.
Sure.
The question is, how do you distribute the KV cache load over multiple sites and racks? I think you covered most of it, but like, do you have a central place to decide how you distribute that, or does it happen on the request by request basis?
Yeah, so it's the interesting story that, so we have a special binary and the global KV cache from the Dynamo. Potentially we're putting the additional binary which pulling into the edge to every point of presence. And we have a relay which sending the events and also to have the all information where the cache on each data center stored on each deployment. And the end model, I mean the POP with our binary and logic will understand that, so if we already have a cache, so we can route this request to this data center, or potentially if we don't have on every data center where the model up and running, so we will potentially route the request from the latency perspective to process this request. So this is potentially reusing the NVIDIA Dynamo caching system, but we have extra layer and also the relay which sending the all caches from each regions where the NVIDIA Dynamo working on the layer above, where we have a point of presence around the globe, to sending from all those point of presence events where the cache is storing. So this is the overall architecture and the logic how it works.
So correct me if I'm wrong, but I got that when you get a new request, you decide where is the best data center to put it, and then when you get the continuation of the same session, you already know that the KV is there, and this is how you distribute the KV between the data centers.
Correct.
Cool. Let's get back to your presentation.
So if you're looking, so if you decide that, so how I can install Everywhere AI. So as I mentioned that, so we are a Kubernetes native platform. So basically we can install on every platform as the public clouds like AWS, GCP, GCore itself. Also on the private side, if you have VMware or OpenStack or OpenNebula, so we can support any kind of the providers here, or also we can install on pure bare metal infrastructure where we can up and running our platform. Moreover, so we can also support what we call Kubernetes at the edge, where we connect any kind of the remote GPU nodes as the working node, which will be interconnected to the control plane. So you can potentially announce any kind of the zones with the single nodes anywhere, which will be interconnected through the public network with your control plane. So on the GCore part, so we are working with the different, as the public provider, with the multiple AI customers, frontier AI labs, enterprises, telcos. We know that, so what the main pains and what kind of the solutions the ML engineers, data scientists, and operational engineers would like to have to running their workloads. Also, so our ultimate goal to providing the super easy way how you can up and running your training or inference tools super easy, but also you can have the access to the engineers who can help with the all optimization and all infrastructure things related from the infrastructure perspective and how it should be connected and meet the reference architecture to the end model side, where we can help with the all things optimization and the application itself to meet your business requirements. And I would like to mention about the Orange use case. So one of the main part with the Orange is to providing the inference for the external users and for internal users, but mostly to meet the sovereignty and data privacy. That's why very important to have the infrastructure which fully compliance by the Orange businesses, but running our software stack on top of the Orange businesses GPUs. And also to providing super easy way how you can deploy the models and also prepare the special models for the end customers, and also to have the air-gapped functionality that we are as the G Core doesn't have the access to the platform at all. So it's fully managed by Orange Business's operational team and AI team, and more for a specific use case will be covered by Orange Businesses in a few minutes. But I would like to cover the demo side, so how it looks like from the end customer perspective.
Before that, I think we have quite some developers on the call. So before the demo, we have two questions that I think are really interesting and relevant. The first one is, do you transport the KV cache over your one, like between the data centers? The question from LinkedIn, actually.
Yes, correct. So we're transferring between our network backbone or the customer network backbone to the point of presence. But in the end, when we deliver the everywhere AI, so it's not should be the G Core point of presence, which I mentioned before. So it can be the end customer point of presence, which can be deployed on their infrastructure or in any kind of the public clouds, which can be distributed in multiple locations. And also, so it will go through the public internet, or potentially if customer has their own network backbone or SD-WAN or EVPN across the multiple data centers. So it can be also optimized from the network perspective. But we suggest to go to the telco providers, which are already working for hard many years, and they have very optimized network where we combine our capabilities and algorithms to sending the all events and policies with their optimized network backbone.
But I think what's important to mention is that you right now are transferring KV cache metadata, not the KV cache, the information
Correct.
about where the KV cache stored.
Correct. So KV cache, transferring KV cache, it's very heavily. So that's why we're sharing the KV cache metadata to also decide that. So which data center has this cache to synchronize the all cache between the data centers. So it's very challenging and very heavy from the traffic perspective. So that's why we're sharing the metadata.
Yeah, and just to comment from the Dynamo side, I think we are now starting to look into transferring the KV itself between the workers. This is already available in the main branch, but it is in the alpha stage. So you are welcome to experiment with that. You're welcome to measure the speedups that you get, and please share those back with us so that we understand if the feature is helpful and important. Dynamo has Discord, as you may know, but for now, the KV cache is only stored where it's generated, or if you have a networking file system connected to that. Sarah, there's one more technical question I think is core to G-Core expertise as well, before we move on to the demo. How do you perform Kubernetes maintenance on these racks while avoiding service disruption and ensuring there's no impact on end users?
Yeah, so first of all, so we have as we have a replication, so we can connect the multiple sites first of all, but inside the Kubernetes, we think that so it should be as minimum 2 nodes. And also we're using the operational system with the green and blue upgrades. That means that so when we upgrade, as an example, operational system or any kind of the kernel system or drivers, so we have a multiple operational system. So it can be rebooting on the fly, and also so if it's going to be uploading, so it's moving back. On the rollout perspective and upgrades, so we're supporting the latest updates on our side, and also we have a versioning and the installer and upgrader from our side, which we're pushing to the end customers to their repo, and they can easily to upgrade our platform on fly. Additionally, so we also understand that so what the utilization in the platform has, the pods can be replicated into the different worker nodes, and it can be upgraded from the worker perspective one per one. But potentially, so the all upgrades doing without the interruption, and especially with the distributed environment, so it's going to be easy when you can roll out the upgrades for one region, for one worker to another, for the end customer, so it's fully not visible.
Well, that's impressive. Thank you for sharing. Yeah, I think now we are out of questions for a small second. Let's get on with the demo.
Perfect. So this is the our self-service portal, which Orange Business is using for their internal usage, where they can run and manage the inference workloads, training tools, but we will focusing on the inference part and the NVIDIA Dynamo. So the customers can able to have their own dedicated models. Also, we're providing the application catalog, but the ultimate thing to focusing into the NVIDIA Dynamo for public models, where the end enterprise can build their own internal token factory, where the end customers can easily generate the IK key using the single AWS endpoint or internal endpoint here, and starting to utilize that. So this is from the end user perspective, and again, we're supporting the multi-tenancy, so the end project, the end account can generate their own IK key for utilization, and see also so how they consume tokens for internal input tokens, output tokens, cache tokens as well. And from the administrator perspective, so the end provider enterprise can easily to deploy any kind of the models from the list which we're providing, including the special builds based on the NVIDIA Dynamo, like Kimi, DeepSeek, and any kind of the models on fly. And I would like to show you one of the examples here. So this is the one of the deployments with DeepSeek V4 based on the NVIDIA Dynamo. And let's ask about the, so tell me about everywhere AI from G-Core. So it's including to my open cloud environment with the in agentic mode, and also so you can see that's how fast it works. So how tokens very fast generating, and I can extra go into the Slack to the any kind of the extra MCP switch connected, but also it's fully secured as this is the my environment based on my GPU, so I'm not sharing the data anywhere, and also it's distributed in the multiple locations. So the my request going to the nearest point of presence with the nearest replica of the model, and also so I can clarify that. So is it support NVIDIA Dynamo? And you can see that so how fast it works. And yeah, so this is how you can build your agentic modes, how you can build your models for physical AI, but also we see that so how it looks like, and how you can easily build any kind of the applications based on the models which we optimize, or based on your models through the platform. And I would like to pass the word to Nicola from Orange Business to describe their use case and how they position that for their end customers.
Thank you, Sarah. Good morning, good afternoon, or even maybe good evening for some people around the call and the webinar. So I'm Nicolas Bugot. I'm leading the AI infrastructure at Orange Business in product and marketing. So today I want to discuss with you 3 points from the business perspective. First, enterprise AI inference, it's scale up and a production challenge we've seen with Sarah demonstrated. What we believe as well is that sovereignty is becoming a policy-driven control plane. And third, the next challenge that we will face is to use GPU more intelligently. So today, this is my story today, and I will illustrate it after the slides, the small demo that we created with AI. Okay, so why are Orange Business in this? We are the telco, European telco B2B division, and we see enterprise AI is intersecting with three domains: networks, cloud computing, and cybersecurity. So AI inference has been a lot on choosing the right model, looking at the charts, the benchmarks. But enterprises, what they do, they ask, can I trust my AI? Can I operate it? Can I go and scale it up and even integrate it fully within my IT, which will be more and more necessary with agentic. So this is our area of focus at Orange Business, especially in Europe and in Asia Pacific. So at Orange, we use daily AI for customer support, for mobile network operations, for daily tasks. We generate agentic AI platforms for our more than 100,000 employees using monthly more than 2.4 million requests. So actually, the Orange Group is our own most demanding AI customers, and it gives Orange Business a very practical view on the enterprise needs. So what we've been seeing with customers, that they are moving from experiments to real production use cases. Here you have, for example, with a custom LLM or industrial design or code modernization in banks or claim automation for insurance companies. These are becoming critical activities, and this is why they need a trusted sovereign AI platform. So with AI, sovereignty is changing dimensions. So it's becoming what we believe a control model with data, operations, legal, and technology. Where are your prompts and log stored? Who operates your AI platform or infrastructure when you cannot? How do you manage compliance and extraterritorial laws? What if you could have more technological choices when you're doing AI? So we believe companies, enterprises need choice in all those four dimensions. And of course, there is no one-size-fits-all sovereignty solution. A hospital, a bank, an industry, they all have different risk profiles. So sovereignty will guide deployment, routing, operations. So it really needs to drive the technical control plane, which I'll demonstrate a bit later. So with NVIDIA, G-Core, and Orange Business, we solve different problems at different layers. Orange Business provide sovereign data centers, network connectivity and backbones, and operations, trusted operations. NVIDIA accelerates AI, improves architectures, and G-Core provides all the software platforms that transform an AI infrastructure into a real service. But even combining all three, many challenges remain. We've talked about sovereignty, but we know that GPU are scarce, very costly. We have huge energy challenges. For private AI farms, underutilization is a big issue. And companies, they need performances where they run their processes with AI. But the next challenge is not adding more GPUs into the equation. It will be, as an ecosystem, to optimize, it is my personal belief, optimize the overall infrastructure, driving this through the AI grid. Sovereignty will drive the infrastructure. And I will demonstrate it to you if you are through a small demo.
You're loading your screen, right? No? Yes?
Yes, sorry, yes. Sorry.
So in the meantime, yeah, I think this perspective of getting to the efficiency on the data center scale level and then on the planetary scale level and what efficiency means, I think that's the question industry is actually trying to answer right now. So that's the forefront we see. Okay, I can see your screen.
You can see, yes. Thank you, Dimitri. So this is a mock-up website, but where we wanted to demonstrate the placement of LLMs and AI models through different criteria, including the sovereignty criteria. So, for example, here you have a model catalog with different LLMs, NVIDIA, DeepSeek, Mistral. You can, of course, filter by what the models can do by the different licenses. It's open source or commercial, but maybe when you need privacy, you want your own private GPU, not a shared model. You want maybe to optimize carbon footprint and maybe make sure that you are AI compliant and the sovereignty index is computed on the fly. And for example, let's choose by accident, it's a French model. So
to open at once for one user.
Offline.
here it's Mistral. So you have the description of the model, it's the model card, all this information are derived from Hugging Face, the files, the benchmark. What's more important, it's here. What about licenses, what you can do, what you cannot do, what are some conditions? Okay, so here it's about sovereignty, compliance, and then you choose your instance type and you deploy. And here you want to deploy maybe by optimizing latency, but for example, being very careful about carbon footprint. So we know that in Stockholm, in Oslo, and in Paris, energy is almost carbon-free. So we choose this, and then we go to the next section, and we want to make sure about sovereignty. What can I do? What I want maybe to lower. Maybe I will accept that some of the logs are not fully stored in Europe. So, and once it is done, I can choose, it's a production grade environment, so I need to scale up and down, scale from 0 to maybe 12 GPUs, and thanks to Dynamo, and it's optimization through KV cache, what was demonstrated. Here you have all the benefits, and even you can predict what would be the request per minute, token per second, and you may want to optimize latency through Orange Business Network. So this is what I would choose. And then I hit deploy. So containers are pushed, models are pulled, loading into the GPUs, API endpoints are up and running, and there you can start working. You have your API, your logs are here, and maybe I want to see already what's happening on the grid. So this is it. You know where bare metals are running. You can monitor which jobs are active and review all the KPIs. So this demo actually shows that sovereignty, performance, and energy footprint, for example, can come together. And so with the AI grid, this vision is not only a vision. It can be a reality. It needs to be orchestrated. And let's imagine if you have those tools into your hands, what you would do.
Yeah. Thank you for your demo, Nicola. I think this is really the tool which actually allows the end customers to understand their decision process about the sovereignty and what they need. I think we have a relevant question to you from the audience. Could you comment on the popular models that you see customers requesting, utilizing in the...
Okay, so yes, our environments are fully like that, and so the models are, for the main part, we see a lot of traction on Chinese open source models, and also from Mistral, and especially about the voice and voice to text, and more and more, I would say NVIDIA, but we have not released yet the Dynamo powered models. Actually, we had what was somehow a failure with a customer last week, wanted to use a GLM 5.1, and we did it without NVIDIA Dynamo using VLLM. And with just a few requests, the infrastructure was fully overloaded and we could not answer or have enough tokens produced, which Seva demonstrated in the opposite way.
Yeah, it's very, very popular at this stage. The all agentic models and software development part to shifting, especially from proprietary models like OpenAI, Anthropic, and everybody thinking about the data privacy, but also right now the budgeting side also starting to be crucial for the companies, which they see the monthly invoices in sometimes, and they would like to also finding the way how they can optimize the models for specific tasks. And that's why the data privacy, latency, and also dedicated endpoints in the specific use cases, it's very, very crucial. But yeah, as Nicola mentioned, the all Chinese models like GLAM, DeepSeek, Kimi, Minimax. So this is the one of the most popular models at this stage in the market, what we see as well.
Do you have an intuition? Why do you have an intuition of like in which workflows they work best, and what's the proportion of those workloads? Like, is it everything agentic already?
Mostly yes, and also so everybody trying to optimize their code developments and also finding the time to market, also the different use case related to the knowledge base and building the embedded models as well. This is another thing. But ultimately, what we see that so majority of the traffic which consumed at this stage, so it's agentic one. And also the overall integration in the tools, which also parsers right now from the Chinese open source models using at this stage. So some kind of it's not optimal or some issues to work with any kind of the tooling. So that's why it's very important to have also optimization on the infrastructure side, or who works and optimize and build those models. So basically, you can take the vanilla version, but it's doesn't work properly. And also, like Nicholas mentioned that, so it's also related to the specific use cases or the GPU infrastructure. So this is the very crucial part. But agentic one, it's the, again, so majority part of the traffic from the LLMs at this stage.
What we see at Orange Business, it's we have, I think, a slightly different customer base and use cases. So we see companies very attracted to sovereignty. For example, for industrial maintenance, what they do some RAG over images, blueprints, to manage very specific maintenance. Of course, code assisting, moving away from cloud code is important, because once you are used to it, even your secret code goes to cloud code, and it creates a breach. So we see more and more companies are wanting to move back. And because of this very performant infrastructure and models, they believe they have their shot, and we believe as well.
Yeah, and do you have some industries which fear most about their code getting to cloud code? what industries do you think are like most interested in the sovereignty and in the secure privacy requirements?
Of course, defense, security. It's it's obvious. Aeronautics, of course, space, all those industries, health.
And
Okay.
the finance.
The last question, I guess, from it may have come from an AI agent, but I'm sure it was a person. The question is, do you have the CLI for all these tools that you have shown in the platform? I guess the intention was for the agents to be able to run it themselves.
Yeah, so for Everywhere AI, so we providing the API SDKs for our customers, so you can easily to apply the SDK to interact with the platform for managing deployment and deploy any kind of the resources in the platform. So this is kind of the nature right now for any kind of the platforms which available in the market to providing the SDKs for interacting, or MCP as an example. So yeah, on our public cloud, we offering the MCP for our public cloud, and also we offering the SDKs for our Everywhere AI.
And at Orange Business, we leverage fully G-Course API. The service you should be able to order it, to support it, to run it, and of course, we use the SDK and the API.
Okay. Thank you, Seva. Thank you, Nicola, for taking this time to chat. Thanks everyone who submitted their questions. We might try to answer more of them in the chat soon if we haven't. And thank you for following us in this journey from the actual deep dive into how we manage KV cache across the data centers to what are actually the requirements to build it securely and with the proper level of sovereignty. We will hope to see you next time in our webinar and in our next conversation on AI inference in about a month. Stay tuned for the channels, the same ones.
Thank you.
Thank
Have a good
you.
day.
Bye-bye. Have a good day.
Bye.
So this was a good one in which they talked about Dynamo, NVIDIA's Dynamo, the KV cache disaggregation service, and how you can manage it for those models. It has been like we knew about it. We have discussed it in our TWIML generative AI impact meeting that happens every Friday multiple times. But this was informative with respect to the models and the new features that they have introduced. So does that. And this is a research paper Quai KI VL 2.0 technical report by KI team. And this gives an open source mixture of expert multimodal foundation model designed to advance long video understanding and agentic intelligence. And there was comment or post reply on X in which people wanted to get info about some guy. Yeah, this guy wanted info about the MOE deep dives. I will share this paper. Plus, there are many new research avenues coming up with MOEs. Yeah, this is distributed aligned VIT pre-training, 2D rope, sequence packing, so unified visual encoding, dynamic resolution, image encoding, dynamic resolution video encoding, adaptive video pixel budget, DSA for long context multimodal modeling, MQA style lightning indexer. So this is the formula for the throughput indexer that follows the MQA key sharing design. So these are the stages. Stage 0, projector initialization. Stage 1, image text alignment. Stage 2, multi-task injection. Stage 3, long context extension. So they use a group sequence policy optimization, GSPO, by Zeng et al. 2025. So this was the diffusion gamma that we were going through. Yeah, you guys can go through it at your own time, since it is centered around noise. So, like, how do we generate signal from noise? What's the reverse diffusion like? How the denoiser and the encoder work together to give a proper high fidelity image. Then there is for mask diffusion, like for text, there's this masked diffusion, and uh, then they talk about what's this? This is mask, and noise. Pick the amount of noise, and on the basis of that, uh, it comes out with some words which could be replaced or until a certain number of steps are reached. Then the denoiser and encoder. It's a greatly researched and in-depth article with a lot of good illustrations in which anyone can deeply understand what's going on. So a huge like to Martin and for the job that he's doing right now. Share it, guys, share it. This is what I discussed. Let me tell you one more thing. This is what I discussed with Sarvam, uh, with their team a while back. Like this was in last year in August, and I was on a call and I discussed this with Sarvam regarding the diffusion models and what are they doing. But like, I guess they didn't have the enough compute to experiment and come up with a viable model that had uh, some use cases. The At that time the their research wasn't good enough to be published, so I think so they put it on the shelf. But I think so they should come out with this research now, as it's like quite uh, feasible with respect to what Google has done and some of the other models that have been produced. Yeah, I got to try this. This is also, the coffee is good, but the girl is great too. This is toasted jaggery espresso range. Iced toasted coconut jaggery espresso. Mm. So we are done with that. Let's work on some SBCs. EAFC 26 SBCs. I don't think so. I will be able to catch the first match today since it will schedule World Cup. It begins at 12:30 in the night. Yeah, 12:30 a.m. Mexico versus South Africa. There is tomorrow morning. Why is it Friday? FIFA World Cup schedule. Is there a good side? Look at the schedule in IST. Indian time PDF. Oh, yeah, it's June 12th. So 7:30 a.m. tomorrow morning, there's South Korea versus this team. And I don't want to butcher the name of the nation here as well as the venue. 12:30 a.m., 6:30 a.m., and 3:30 a.m. Mhm. Thing looks like I should be doing maybe this guy here, 5 cross 87. It requires this team of the week or team of the season player, which again uses 84 rated player, 11. Oh, what EA has done is they have reduced the number of packs that people are getting. Everything is based on tokens now, the FOF tokens. These tokens, the 1,000 tokens that I have. So it's difficult to get the players there. You can see on the transfer market players like Van Dyke. I think so, 10k as the base price. One at 9.8. Everything is spiked up. Since there is a dearth of packs in the market right now, so people aren't opening it up. Even the squad battles, champions, rivals, everyone is just giving FOF tokens or some points right now, so there's that problem issue uh, that people are grappling around with. And also, what I wanted to show you guys is that I talked to Asus and they say that they might be willing to collaborate to give me a Pro Art P16 or 14 with a NVIDIA RTX Spark processor to test it out. So I will be waiting and will DM them if they are willing to send me a one.
It's in the game.
This unlocks in 1 day, 3 hours. Start whatever it wants. Rivals, yeah, it's available. Mission 5, that's great. 40k coins, 400 FOF tokens. So the Journey of Nations, I wasn't able to complete it yesterday because of only 6. No, no. Yeah, season 8 exhibitions I wasn't able to complete yesterday because I had only 6 attempts. Yeah, it has refreshed. 6 days, 17 hours. So what I need to do every day is play season 8 exhibition and Journey of Nations to I think so to have any evolution players. Yes, this is pending right now. This is it. Okay. Let's view my squad. If I apply not available, he might be able to get CB. From 76 dribbling to 87 dribbling, 81 passing to 86 passing, 41 shot to 86 shot, 94 defending to 95 defending, 94 physicality to 95 physicality. And overall is maximum 91. So I think so this is the best bet right now. And it only applies to CB. Or maybe Hanko if I what's the name? Only applies to maximum 91, so not him. I don't have any player which is max 91. Maybe that guy, the RM, the RRB. Let's search for. maximum 90. This is max 92. That's max 89, max 89. I don't think so I will be able to apply it to anyone. Uh-huh. Free kick mastery, maximum 90. Backbone brilliance. Maximum 90. Players. Maximum 91. And copy it. Yeah, I will apply it to, because I don't know if I have any other player here. Just want to see, and chasing the spotlight must be. This is max 90. Try again tomorrow. Yeah, Aziz, maybe I will be able to apply this to Aziz or Van Evic. He goes 92. So from 87, he goes to 92. Yeah, let's start this evolution. Street so relentless rise. Maybe to Gilberto Silva. Pointless rise. We took Aziz. Now Aziz is on a different path altogether. This could be the must not be CBRCN. Yeah, Hincapié is the best option here. Maybe Gilberto Silva. Acceleration +3. Speed +2. It goes to 93. Not the point. Hincapié is much better option here. Yeah, I've also seen people evolving Van Dyke to 99 plus pace or something like that. And their chain gold standard or something like that. But I wasn't able to find that. I think so it is on the store or something. Token store. There was this gold standard Evo. Yeah, I'll be with the gold standard Evo. Golden standard or gold standard, something like that. This is the playstyle plus labs. Playstyle labs, rewards. Rules. Cosmetics. This was a gold standard. Didn't find this app anywhere. 500 FOF tokens. I need new token store 500 tokens. So here it is, gold standard, but I do not see it in the game, in the FOF token store. I only have two options here: seasonal token store pack 3 and seasonal token store pack 4. That's the issue. I was trying to find out. Yeah, where is my gold standard FOF token pack? I do not even see the one step ahead FOF token store. I guess we'll quit streaming for a while until this gets over. So we'll see you guys on the other side.